Hi, and welcome to this demonstration of the commit analysis infrastructure developed by the University of Hildesheim for Work Package 4. In this video, we will focus on the extraction capabilities of this tool. In particular, we will show you how to switch between different variants of the extraction between different types of software repositories and their commits. The purpose of the commit analysis infrastructure is to provide information about the evolution of a software in terms of introduced changes to certain artifacts. Its process therefore consists of two steps. First, it extracts commits from a software repository. Each extracted commit provides a basic information about itself, like the commit number, the commit messages, and so forth, and each changed artifact including the changed lines. These commits are input to the commit analysis, which is the second step of the process, and provides the final commit analysis results. The commit extraction is the focus of our work in Work Package 4 to provide evolution data and artifact changes as a basis for their analysis. The commit analysis part is more a subject to other work packages, like Work Package 6, where we use this infrastructure as part of our incremental product line verification approach to detect artifact changes and their impact, and to reduce verification effort by reducing analysis to artifacts affected by those changes. Further, we plan to use a similar change identification in Work Package 5 to detect divergences between artifacts of the problem and the solution space during evolution. The main features of the commit analysis infrastructure result from its architecture. A commit extractor is used to extract the commits and their information from software repositories. This component is a plugin, which the infrastructure loads at runtime. In this way, changing the way of extracting information from a software repository is only a matter of switching between different commit extractors. Each extractor provides its information in terms of elements of the infrastructure data model. These elements are input to a commit analyzer, which is again a plugin to enable different analysis of commits and their changes, and hence different analysis results. A configuration file specifies the particular instance of the commit analysis infrastructure. It defines the software repository as a source for the commit extractor and the directory to which the commit analysis saves its results. Further, the configuration file contains the exact definition of the particular commit extractor. Currently, we offer two extractors, one for Git-based software repositories and one for SVN-based repositories. Additional extractors can be developed easily by following the guidelines of the infrastructure documentation. In the same way, the configuration file defines the particular commit analyzer. Here we offer two different ones. The variability change analyzer identifies the frequency and the amount of changes developers typically apply to specific type of artifacts in practice, while the dead code change analyzer is used to detect relevant changes for the dead code analysis in Work Package 6 to reduce the re-verification effort to artifact affected by those changes. Now we will focus on the extraction of commits and their changes. Each commit extractor offers three different variants of how to extract this information. The first variant is a full extraction of all available commits. The second variant enables the extraction of a user-defined subset of the commits. This subset has to be defined in a commit list file, which contains the numbers or hashes of the commits of interest. The commit list file has to be specified as part of the configuration file of the infrastructure. The third variant does not provide an extraction mechanism in the sense of the previous two variants. It allows to pass the content of a single commit as an additional input on the command line when starting the infrastructure. Hence, the commit content needs to be available, while the previous two variants extract exactly that information. However, this variant is beneficial when using the infrastructure as part of a version control system. For example, one can call the infrastructure as a part of a pre- or post-commit hook to pass the current commit on the command line for analysis and accept or reject the commit based on the analysis results. In the remainder of this video, we will show you an example for each of these three extraction variants. We will start with downloading and installing the commit analysis infrastructure. Then we demonstrate how to define a particular instance for the full extraction of all commits from an SVN repository. Next, we perform a partial extraction by defining a subset of commits from a Git repository. Finally, we show how to call the infrastructure with a particular Git commit as a command line input. Let's start with the hands-on demonstration of our tool by downloading and installing it. Therefore, we navigate to the GitHub website of the commit analysis infrastructure. Here we find multiple repositories for the main infrastructure, the individual plugins, and some projects for testing them. To obtain a full release, we open the ComAnI repository, which hosts the main infrastructure. In the release directory, we download the ComAnI zip archive to our favorite location. After this download, we extract the content of that archive to a directory of our choice. This directory represents the installation of the commit analysis infrastructure, which contains the core infrastructure plugin, the available commit extractor and analysis plugins, the guide, and a template for defining the configuration of our desired infrastructure instance. In addition, we define two subdirectories, one for saving analysis results and one for caching extracted commits. While the former is out of scope of this video, we will use the latter to show how the infrastructure represents commits and changed artifacts later in this video. Another prerequisite for applying the commit analysis infrastructure is the availability of a local copy of a software repository. We prepared the system in advance by cloning the Linux kernel repository as an example for a Git-based repository, and the AXTLS repository as an example for a SVN-based repository. With all that done, we are ready to perform the full extraction of all commits from the SVN-based AXTLS repository. Hence, we open the template properties file to define the respective instance of the infrastructure. First, we need to define some core properties, which are the path to the directory in which the infrastructure finds the plugins. That is the directory to which we extracted the release archive. We further define the type of the version control system of the repository. This is required as the infrastructure checks the individual plugins for support of that version control system during setup. If they do not support them, it terminates and informs the user about the specification of a wrong extractor or analysis plugin. We'll delete the parameters for log level and commit queue elements as they are optional and not relevant for this demonstration. The second part of the configuration file contains parameters related to the extraction step. Here we define the desired commit extractor by its fully qualified main class name. That name can be found in the description of the plugins repository. Further, we define the path to the target repository as an input from which the extractor shall extract the commits and their changes. The commit list file is not required for the full extraction, but later for partial extraction. Hence, we only comment it out. Finally, we define the path to the cache directory where the extracted commits will be saved for reuse. While this is an optional parameter, we will later have a look into one of these commit files to see what information is available. The last extraction parameter is not of interest here, so we simply delete it. The last part of the configuration file defines the desired commit analyzer, again by its fully qualified main class name and the directory in which it will save its results. The analyzer requires some plugin-specific parameters to work, which we have to define here as well. However, as we focus on the extraction, we will not discuss their purpose at this point. Detailed explanations can be found on the GitHub websites of the analyzer. We save this configuration as a full extraction properties file, start a terminal session, and start the commit analysis infrastructure with our new configuration for a full extraction of all commits. This extraction takes some minutes to finish, such that we speed up the video a bit at this point. After the termination of the infrastructure, we can have a look into the cache directory, where we find all the extracted commits as individual files named by the revision in the SVN repository. Each file contains the general information about the commit, and each changed artifact with its entire content, including changed lines. Now, we want to extract only a subset of the available commits of the Linux kernel Git repository. We therefore have to define the commits of interest by the commit hashes in a separate commit list file. That is a simple text file which contains each commit hash in an individual line. In this video, we only define the 3 most recent commits to the master branch and save the file at our favorite location. Next, we have to adapt the configuration file accordingly. We change the core parameter defining the version control system from SVN to Git, exchange the SVN commit extractor by the Git commit extractor, adapt the path to the input repository to use the Linux kernel repository as an input, and define the commit list file to restrict the extraction to those commits specified in that file. We save this configuration again with a different name and execute the infrastructure passing this new configuration. Having a look into the cache directory again, we see that now only 3 files exist, which represent the 3 commits defined in the commit list file. Each commit file contains the same information as in the full extraction variant, but from a Git-based software repository. The last extraction variant requires the content of a single commit, which we then pass on the command line to the infrastructure. We therefore use a small Git commit that we extracted previously for this demonstration. As the previous configuration already defines the Git commit extractor, we only need to start the infrastructure again with that configuration and append the commit content with a special string at the end. That string is used to detect the end of the input commit by the extractor. When we now navigate to the cache directory and open the commit file, we see that it is exactly the same commit as we passed as an input. In summary, we showed you the extraction capabilities of our commit analysis infrastructure. More information can be found on the GitHub websites and in particular the infrastructure guide. Thanks for watching this video.